Okay, so now what I'm gonna talk about a topic. It's just an alternative way to calculate conditional probability in terms of odds, which gives a little bit more intuition, maybe behind how we might use conditional probability. And it's also a precursor to what we're going to be talking about later on in uh, terms of expected value. Okay. So definition. The odds on an event, sometimes also called the chance odds. And the reason why I say chance odds, because they're not necessarily, there's a difference between the odds that you calculate, the fair odds based on your model, and the payoff odds that you're being offered. If you're being offered a bet, for example, odds can be defined just in terms of probability. The odds on an event A are defined by we'll write odds of A is equal to probability of A divided by 1 minus probability of A. Conversely, if the odds on A are given as X, then the probability can be recovered as X over 1 plus X. Okay. Okay. In the betting world, this way of calculating odds is called fractional odds. This is a little bit of an aside, not totally necessary for this class, but there's all different types of odds that you might come across in a casino. This is how odds are typically going to be written in a casino, but not necessarily at a sports book. There's different ways of expressing odds, payout odds. So these are chance odds. Payoff odds for a bet. Let's define the payoff odds for a bet on A. So I might also call these the fair odds. Fair odds based on P. And we'll see why those are considered the fair odds in a second, or in a few minutes. Payoff odds for a bet on A are the net gain if we win divided by the stake. So 4-1. So if payoff odds are 4, payoff odds equals X means I win X. So if I win X for every dollar bet. if A occurs, or I lose my stake. Okay. So if the payoff odds are 4 and I bet $100, then if I win, I'm going to win $400 of profit. If I lose, I'm going to lose $100. Okay. And in betting, a game can either be called advantageous, fair, or disadvantageous. If the chance odds, I call them the fair odds, times the payoff odds are either greater than, equal to, or less than 1. Make sure I'm getting that right, actually. Okay. Okay. So they're kind of inverted, but why we call the fair odds. I'm going to call them chance odds. Why I called them the fair odds is if the chance odds times the payoff odds equals 1, we call the game fair. What does it mean for them to be equal to 1? Well, that means that the payoff odds are equal to 1 divided by the chance odds, right? And if we do that, then we're gonna recover. So if we're told this, then we can recover the same probability. In other words, the market odds imply the same probability model as our model, or as the true chances. So the odds are priced in a manner fair with the actual probability of the outcomes. Okay. Okay. We're not talking about really about betting in this example, but it's one way to look at it. I want to show how we can do it in case of a diagnosis of an example here of a diagnosis. So how we can interchangeably write things in terms of probabilities or in terms of odds, depending on what we prefer. So a doctor is initially %60 certain that a patient has a disease. So he orders a test. So the test is ordered, and if the patient has a disease, so here's the conditions of the test. So if a patient has a disease, the test always gives a positive result. Test is always positive. Meaning the test always knows if the disease is there. Now, for a diabetic patient, without the disease, there are 30% false positive rate. So what that means is that if the patient's diabetic and does not have the disease, the test will still return a positive result, suggesting there is a disease 30% of the time. This patient is diabetic and obtained a positive result. So then what's the chance that the patient has the disease, right? So then, what is probability of disease? So now this is a conditional probability, right? We started out with a 60% probability. And now we have additional information, which is that there's a positive test. So first of all, let's let D be the event that there is a disease. Let's let plus denote the event of a positive test. Okay. What's the probability having the disease given a positive test? Well, it's the probability of having a disease and getting a positive test divided by the probability of a positive test. What's the probability of having the disease and having a positive test? We can use multiplication rule, probability of having the disease. So this is the prior probability, 60% times the probability of a positive test given the disease, which is 1%, which is 100%, right? If we have the disease, we always get a positive test. What's the probability of a positive test? Well, now we have to break up the positive, break this up into the situation where we have the disease and don't have the disease. So this is the law of cases, right? So we're going to have a positive test, and we can have a positive test under two different scenarios where we have the disease or don't have the disease. So what do we know? Probability of a positive test is probability of a positive test given that we have the disease times probability of the disease plus probability of a positive test given that we don't have the disease times the probability we don't have the disease. Okay. So numerator, probability of a positive test given the disease is 1 times the probability of the disease 0.6. Okay, that's also the first term in the denominator. But then the second term is probability of a positive test given not having disease. What is that? For a diabetic, 30% false positive rate times the probability of not having the disease. That was 40%, 1 minus 60%, right? So this is 60 divided by 72. We calculate this, it's 5/6. So that's just a way that we would calculate the conditional probability given what we already know. But we could also alternatively calculate the posterior odds. So alternatively, we can calculate the posterior odds. This, by the way, I should say, this is called a posterior probability. Posterior, post means after. This is the probability that we get after we take the test, right? So it's after we condition on information. So we start out with an opinion, in this case, 60% disease. We say, okay, let's collect more information and then let's update our probability given that information. So we have a prior probability, a probability prior to calculate or collecting the additional data, and then we can calculate a posterior probability. Similarly, we can calculate posterior odds. Posterior odds. So these are the odds of disease given positive test. By definition, what are odds? Odds defined here. Probability of A divided by probability of A complement. In this case, it's conditional, so it's probability of D given a positive test divided by probability of D complement given a positive test. How do we express that as conditional probabilities? It's probability of D n positive over the probability of positive, probability of D complement n positive divided by the probability of positive. The probability of positives cancel out. But we can also then flip around the top, just like we did here. We used the multiplication rule. So we can do on the top, probability, positive given D, probability of D, probability of positive given D complement. Probability, positive given D, probability of D, probability of positive given D complement, probability of D complement. Okay, how do we interpret this? Well, this was the prior odds on D. And this here is the likelihood. It's how likely it is of being positive given D over the likelihood of positive given D complement. So it's the likelihood ratio under the two conditions times the prior odds. So we can express this posterior odds in terms of so the posterior odds on D are the prior odds updated by the likelihood ratio. So that's just a concept. We take the prior odds and we modify them based on the likelihood ratio, the likelihood of observing the positive test under the different scenarios. All right, next we're going to talk about Bayes' rule.